Oh, g'day champions. Got the same t-shirt on. I'm doing all the videos in the same day. It's crazy, I know. Got a JCM900 head here. It's come in with channel B, no gain, and blank tone. So that was the description. Sometimes you've got to sort of spend a bit of time thinking about what the guitarist could be thinking when they say things like blank tone. Maybe it's really dull sounding, like maybe no top end. There's sometimes a little bit of outside the box thinking required there, but this has a few common issues on this unit. Usually the channel switching is the first thing to go, so we'll check that out. He's just bought it, so he's not really used it since he bought it. Scratchy pots. A lot of sellers will come here and get the thing serviced before selling it, and I really respect that. Some people just sell it as fully functional and it's got lots of issues, and then they pretend like they didn't know. Sometimes they sell it with issues for a reduced price, but not sure what the situation was here, but we'll get to the bottom of it, figure out roughly what it's going to cost him, and then come up with a game plan. Alright, so we're over at the bench. Here's the guts of this thing. Sort of a crossover as Marshall started going towards more efficient production methods, but they still had the chassis mounted valve sockets you can see in the split down between the two boards there. This is kind of not a bad way of doing it in my opinion, because you've got the heat generating valves, you know, large mass mounted in the sockets, mounted hard to the chassis, and then you've got wires running to the circuit boards, which allows for swift manufacturing. One thing I don't like is they use rivets on these valve sockets, so if you've got to replace them, you've got to stuff around drilling the rivet out instead of just undoing a screw. And sometimes there's some heat damage to the board around this Zener regulation here. It's similar to the sort of Fender style of doing things and very inefficient, generates a lot of heat. There's less power involved in this one because it's just powering a couple of op amps, but there's better ways to do that with less heat generation. So I've checked all the fuse ratings, everything's cool. So all in all, it doesn't look like any work at all has taken place. We'll remove that front board, have a look, figure out what's going on, figure out why that channel is sounding very quiet and dead, and then go from there. The only real sign of any rework I found was just some dodgy looking soldering. There it is with that sorted. Just pass through the eyelet, fold it over. No need to wrap it around 50 times, just better than just passing through. We call that poke and pray. So this is one of those models that only has grid stoppers on 2 of the 4 output valves. I still haven't found a definitive reason why they thought that was a good idea. Sometimes with amp manufacturers you'll go crazy trying to figure one out, but the general consensus is it's something to do with sort of offshoots of hi-fi designs. Yeah, I can't think of a reason why you'd only have grid stopper on 2 of the 4. Alright, so we found, I just had to dig in and get this underway because I'm really behind schedule as always. We found that one of these switching op amps had died and wasn't switching when it should have been. I also found some tin whiskers inside some of these pots. I'll show you a close-up now and we'll run through what they are and what causes them. A little bit of history about them. So, champions, tin whiskers, pretty weird phenomenon. It's a thing that happens with alloys when they're placed under stress. The stress may have occurred during manufacturing here. You can see those little pot tags where it's grown out of. It seems to have grown out of wherever there's been like a cut, like a guillotine press, or wherever there's been like that rivet hole sort of punched in them. So that sort of aligns with the theory that they originate wherever there's stress involved in the metal. So you can see here, this is an article from NASA. Wow, they must know what's going on. I mean, shit, if you can fake a moon landing... No, just joking, that's 100% happened. Oh, shit. I'm in trouble. with all the conspiracy theorists. Tin whiskers are electrically conductive crystalline structures of tin that sometimes grow from the surface where tin, especially electroplated tin, which is basically all the tin we deal with electronics, is used as a final finish. Tin whiskers have been observed to grow to lengths of several millimeters, and in rare instances grow to lengths in excess of 10 millimeters. Numerous electronic system failures have been attributed to short circuits, sorry I can't speak, caused by tin whiskers that bridge closely spaced circuit elements maintained at different electrical potentials. So, for example, our potentiometer terminals, which we just showed, they're not a new phenomenon, blah, 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 blah. Here's another image of it. Now, they're referring to dendrites too, so that's a different phenomenon. But yeah, have a look at this article. I'm not going to read through it all. You guys have eyes, or most of you do. I can't speak for everyone, but that is the cause of a lot of problems in electronic devices, and amplifiers are no exception. So long story short, champions, the solution to this particular amp and its low output issues was a combination of one of the ICs failing, but then we found some more issues which were caused by these tin whiskers. So the cure for these was to blast with compressed air the whole amp, but mainly the pots, and then the whole amp, and then give them a clean lubrication. And everything was fine and dandy after that. So if you have similar issues, try that. You may have to remove the pots, maybe use a brush or something if they are being a bit stubborn. This is a good one, isn't it? Under some electrical atmospheric conditions, whisker shorts may vaporize into conductive plasma. My favorite type of plasma, of metal ions. Imagine that. Tiny little, like, microscopic hair triggers a short and does that to a transformer. That'd be great, wouldn't it? And we think we've got messy stuff to clean up in amps. But yeah, check out that. Wikipedia article's not bad either. No one truly... Whoa, look at that one. Looks like this steak I left in the fridge for too long. No one... I don't think anyone really knows exactly why it happens. Oh yeah, there you go. Mechanism behind metal whisker growth is not well understood. And that's Wikipedia. So that's saying something. But I digress. So anyway, back to the amplifier champions. Now I did notice some missing fiber washers on the rear board there. You can see 1, 2, 3, 4 out of 6 have them. There's 2 missing. What that will do is put undue stress on the solder connections as you tighten that nut up, so I'll replace them, but we had to remove the board to get to it, but that gives us opportunity to check all the solder connections on the bottom as well while we're here for peace of mind. And another thing to do while we've got the board out is just make sure that these resistors, see they've got sort of integral standoff stakes there. Just reflow the solder joints and make sure that they're seated all the way home, because it can rip the pads if there's any movement there. You might be able to make out these little spikes there that act like shoulders. They're like the mechanical support to make sure it's bedded against the board, and then the solder connection will have less stress on it. Manufacturers have a habit of not making sure that they're seated home before they flow the solder on. Another weak spot in these, which is pretty critical, is the capacitively coupled bias supply. That is an X-class cap there, and each time they cop a bit of a spike, it actually like vaporizes a bit of the foil and its capacitance drops, and as its capacitance drops, so too does the bias supply voltage, to the point where it becomes unable to be biased correctly, and it will run away and get too hot and damage the output stage, etc, etc. So I'll change that out with a 630 volt rated cap, which is not X-class, and that will ensure greater longevity, champions. The last 4100 well, type amp, I think it was the 4102, the combo, had a burned out power transformer because this cap failed, and then the owner put in, you know, a higher rated fuse on the HT, and yeah, you guess the rest. So let's change that out. We won't have those problems with this particular amplifier in the future. Rock and roll. Alright, so we've got the board back in. All of those fiber washers are installed now, and I tighten it with a 15mm socket just in my hand, so no wrench on that, otherwise you might strip the plastic threads. Those washers are really important because basically these jacks are the only means of mechanically securing this board, aside from the two little screws there on the IEC input. And there's our new Panasonic bias coupling cap there, 1.25 kilovolt. She ain't going nowhere anytime soon. And I've just leaned it away from those resistors so they can get a bit more airflow. Just giving the top of the chassis a bit of a clean. These Marshalls get pretty filthy because of the vent in the top. Someone's actually marked at some point which valve goes where with texture on the chassis. Oddly enough, they haven't marked number 2. That's a bit weird. So the cap's dated 96. Probably not a great idea to leave them in if this was going to be a main gigging amp. So I'll discuss that with the customer. Having said that, those LCRs tend to last an ungodly long amount of time. That's probably some of the longest lasting caps, you know, holding on to their performance out of all the ones I've encountered. But luckily for once, this is the first amp I've had in a while that hasn't had Vaseline or something slathered on the valve socket, so that's a plus. Now you can see here that looks a bit like a stain, but that's actually etching damage in the glass from these retainers rubbing on the glass for however many years. These look like the original valves, Sovtex that came with them at the time. But yeah, that's not a residue, that's actually like etching in the glass, so that could cause the glass to fail in the future. But these retainers in a valve head, where the valves are upright and the sockets are nice and tight, these are kind of unnecessary. I mean, sure, like if you're really rough handling this thing, they could become unseated, but yeah, they're not great with the pressure. They should at least have some kind of silicone washer under it to protect the top of the valve. Alright, so everything's back together. We can give it a test now. Everything's cleaned up, the valves are back in. I replaced one of the sockets, which looks aftermarket anyway because it's got a pointer and a set screw, and the others are just slip on, but there's a crack down the middle of it, so I've replaced that one. It looks a little bit out of place, but it'll fade over time and match the rest of them. So let's fire it up and give it a test. Okay, so I previously adjusted this to about 55% bias, and this shows you that last cap was on the way out. The new coupling cap there, without changing any settings, is down to about 40%. So that means the voltage that was being coupled is greater now, more negative than it was before. So that shows you that the old cap was on its way out. So we'll readjust that back to where it was before, and now we can rest easy that cap's been replaced. That's a common failure point in these models. So there you go, champions, just a quickie. A pretty straightforward one for once, not a complete rebuild, thank God. So I'll catch you on the next one. Take it squeezy.